One way to make sodium sulfate is through the reaction of sulfuric acid and sodium hydroxide. So we have, and this is kind of what your problems are going to look like. So you have sulfuric acid plus sodium hydroxide. And it says how many grams of sodium sulfate can be produced, and then it gives you the rest of the information. And I don't know about you, but I look at these kind of problems and kind of want to hyperventilate, okay? It's like, oh, who knows? Who cares? You know, it's just, oh. Okay, so I don't want you to hyperventilate. I want you to take your time and think through this. You're going to breathe, you're going to pray, and you're going to say, okay, Mrs. Frady said that if I take this one step at a time, I can work my way through this. And I've practiced so many of these, I know I can work my way through this. The first thing you're going to do is the equation, because then you're going to set up the equation the way I taught you, and it's not in the book, it's the way I taught you, okay? So first, Geneva, is this going to make salt and water, or is it going to make ions?
Yeah,
see it there?
Yeah,
okay. Oh, okay, no. That, when that's hanging off there, we're going to make salt and water, okay? And so for the benefit of those people that aren't comfortable with that water thing, I'm just going to put the water, and I'm going to put the salt. So this one gets the 2. And so to balance that equation, you would have to have 2 sodiums, and then you're going to make 2 waters here. So we're going to go like that. Yes, Geneva?
Can it be HO or does it have to be OH?
It has to be OH at the back for it to make salt and water.
So I just had it backwards.
Yeah, has to be that. Okay, so far we've got a balanced equation. You got to start there. Then we're going to put in our information. And it said here, how many grams of sodium sulfate, so we're looking for grams of sodium sulfate, can be produced if 500 mils, we're over here at sodium hydroxide, and we have 500 mils of this, and it's a, I'm sorry, I ran out of room. It's a 1.6 molar solution. There's the information. Now, you're always going to go from where there's no question mark to where there is a question mark. And the only way I can get from here to here is through stoichiometry. I have to go through the moles. It's the only way I can get back and forth on a chemical equation. So I have to get this information to moles. I know that 1.6 molar means moles per liter. I have it memorized that molarity is moles per liter. If I multiply that by the liters, which is given to me, I move my decimal place back 3, there's my liters. What's going to happen? I'm going to be left with moles, aren't I? So when I do that, it's going to leave you 2 significance figures, 0.80 moles of sodium hydroxide. Now once I'm there, I can go through the stoichiometry, moles of sodium hydroxide, moles of sodium sulfite. The reason I did that is because that's where the question mark is. And I'm going to put a 1 here, and I'm going to put a 2 here, just general stoichiometry. And so that's going to give me 0.40 moles of sodium sulfate. And then once I get that, I can go to grams. I just go 0.40 moles of sodium sulfate times line, moles of that to the grams of that, and I'm being short for time. So 1 mole, I'm going to add this up, 4 times 16 plus 32.1 plus 2 times 23. And so that's going to give us 142.2, excuse me, 0.1. Yeah. And so 3 significant figures here, but I only have 2 here, so my answer has to be in 2. So it's going to be 57 grams of sodium sulfate. Does everybody see how that's done? Yes, ma'am.
Why did you move the decimal and the 500?
Because molarity equals moles per liter. That's milliliters.
Oh, you just put in. Okay.
So I put it in liters and then did it. Okay? Is that the only question there?